Let's solve some logarithmic equations. So, here's a couple. Ultimately, what you want to do, you want to make sure you only see log in the equation one time, and then you're just going to switch from logarithmic form to exponential form. So here we've got log base 2 of x minus 4 equals 3. I'm going to grab the base. The base is 2. And here is my exponent, the 3. So 2 to the third equals 8, not 8, x minus 4. And solve this equation. So 8 equals x minus 4. Add the 4. 12 equals x. Easy peasy. Next one, we look at this. I've got 4 times the natural log of 3x equals 8. First thing I'm going to do is we're going to divide by the 4. I want to make sure that that natural log is all by itself. So I've got the natural log of 3x equals 2. Now you're going to switch to exponential form. So the natural log, the base is e. So I grab the base, e to the second power equals 3x. Divide by 3. X equals e to the second power divided by 3. That would be a perfectly acceptable answer, but those of you that are attached to your decimals, it would be approximately 2.463. That's e to the second power divided by 3. Next example, we've got the log of x plus the log of x minus 3 equals 1. Okay, so for this problem, I see log more than once, so I need to write it as a single log. So all that time you spent expanding and condensing, this is where that comes in. This is an addition. Since this is addition, that means you're going to multiply the arguments of the log. So it's going to be the log of x times x minus 3 equals 1. Okay, so I'm going to switch to exponential form and distribute that x in the next step. The log, there's no base written there. Since there's no base written there, it is base 10 because that means it's a common log. So 10 to the first power equals x squared minus 3x. Well, 10 to the first is just 10. I see x squared, which means I have to move everything to one side in order to solve it. So I'm going to subtract the 10. We're going to get x squared minus 3x minus 10 equals 0. And my favorite F word, we get to factor. Okay, so this will be x minus 5, x plus 2 equals 0. Set each factor equal to 0. X minus 5 equals 0. X plus 2 equals 0. X equals 5 and x equals negative 2. Now, here's where we have to be a little careful and we have to check. If I take x equals 5, put it in there, yes, I'm good. If I take this negative 2, okay, x equals negative 2, but wait, can I take the log of a negative number? You got to think about your domain of a logarithm. Domain of logarithms are all positive numbers, okay? So that is an extraneous solution. We get those sometimes. Next problem. I guess it's example D. Okay, example D. This time we're going to do natural log of x minus 3 equals the natural log of 7x minus 23 minus the natural log of x plus 1. I've got logs on both sides, and this side has log twice. So I'm going to condense that one first. So this side I'm not going to do anything with. Natural log of x minus 3, I'm going to leave it alone. This is going to be the natural log of, subtraction becomes division. So it's going to be 7x minus 23 over x plus 1. I got a log, the natural log of this equaling the natural log of that. So I'm going to drop the log right out of the picture. Bye-bye log, and I'm going to set this equal to that. So x minus 3 equals 7x minus 23 over x plus 1. And then I'm going to multiply both sides by x plus 1. Okay, on this side, those two just cancel. This side, we're going to multiply it out. So I'm going to FOIL. It's going to be x squared minus 3x plus 1x, so minus 2x. And then minus 3 equals 7x minus 23. Oh, I see a squared thing. So that means I've got to move everything to one side. So I'm going to add the 23. I'm going to subtract the 7x. So I've got x squared minus 9x plus 20 equals 0. My favorite F word, factor. We're going to factor to x minus 4, x minus 5. X minus 4 equals 0, x minus 5 equals 0, x equals 4, x equals 5. Both of those are positive, yay. That means they're both good solutions. So the solution set would be considered the set of 4, 5. Okay, so enjoy.